All right, welcome back, everybody. We're going to today do just a couple examples that are a little bit more complicated and have some decimals and fractions involved, but the same steps, just to make sure the decimals and fractions don't throw us off. So here are my steps. Steps for solving two-step equations. Simplify. We're going to do train tracks. Remember, simplifying involves distributive property to get rid of parentheses and combine like terms, if that's relevant. Train tracks, undoing the constant, undoing the variable, solve, check. Okay, these are in your notes already from yesterday. No need to write them again. The reason we're undoing the constant first, remember, is because we're doing order of operations in reverse. All right, so order of operations is PEMDAS. When we're undoing something, we're kind of walking backwards through this order to kind of take away one layer at a time. So we're working backwards to get back to where we started. Okay, so remember, addition and subtraction happens last in order of operations, so that's the first thing that we undo. Okay, before we undo the multiplying and dividing, which would be the variable term, right, the coefficient on that variable. But the idea behind this is that we're doing SADMAP, we're doing order of operations in reverse. All right, so let's look at this example here. First, I check see if there's simplifying to do. There is not. There's no like terms. There's no parentheses. We're good. Again, 2 and 10 are like terms, but they're not on the same side of the equation. So when I say simplify, I mean simplify each side of the equation. Okay, this is as simple as it can be, and this is as simple as it can be. All right, train tracks. Okay, I'm going to undo the constant. So again, the idea is if I knew what x was, I would first multiply it by 2/3, then add 2, and that gives me 10. So if I'm working backwards, I want to get rid of the 2 plus 2 first. Okay. So that tells me 2/3 x equals 8. Okay, so before I added the 2, I was at 8. Now I got to get rid of the 2/3 because x is being multiplied by 2/3. I'm going to divide by 2/3. So x equals, I'm going to bring this down. So I got x on this side. I'm going to do 8 divided by 2/3. Remember, keep, change, flip means 8 times 3/2. Okay, before I multiply it, I'm going to see if there's anything I can reduce, and I can. 8 and 2 can both be divided by 2. So do that and get 4 and 1. Okay. 4 times 3 is 12. 1 times 1 is 1. 12 over 1 is just 1. Okay, so my answer is 12. Okay, remember to check that. What we're doing is we're replacing the variable with what we're saying the variable equals. So I go back to my original equation and just replace that x with a 12 and make sure it works. So I do 2/3 times 12 plus 2, and I should get 10. Well, 2/3 of 12 means 2/3 times 12. We can multiply that or just think, well, I know 2/3. A third of 12 is 4, so 2/3 of 12 would be 8. And 8 plus 2 is 10. So checks out. Okay. All right, let's look at this next one. Move your hands a little bit. All right, so simplifying, there's no like terms to combine, no distributing to do, so I go right to my train tracks. Okay, again, if I knew what x was, I'd multiply it, then subtract. So to work backwards, I got to get rid of the subtracting by adding. That gives me 0.15x equals 3.75. Okay, and I got to get rid of that 0.15 by dividing by 0.15. And here's where I got to remember some decimal division. So 3.75 divided by 0.15. Remember, it's okay to have a decimal here, but we do not want a decimal here outside. So to take care of that, I got to move the decimal over 2 places. And then I got to do the same thing here. Okay, so the decimal here is now after the 5. All right, so now it's 375 divided by 15. So does 15 go into 3? Nope. It does go into 37 2 times. Just 30. 7 left over, bring down to 5. And 15 goes into 75 5 times, and exactly 5 times. There's nothing left over. Okay, so I get 25. I don't have anything after the decimal, so I don't need to include it. It's just a whole number, 25. Okay, to check that, I'd again replace this x with 25. So 0.15 times 25 minus 3. Okay, so you might want to do plug this into a calculator if you're checking, or we can do our decimal multiplication. 25 times 15, that's 5, 2, 12, 0, 2, 5. Add them up. 5, 7, 3. 2 numbers after decimal. There we go. All right, so 3.75 minus 3 would be 0.75, which it's supposed to be. That checks out. All right. All right, for this one. So this one, we do not have a constant to undo. So this is kind of one of those rare ones. People asked about this yesterday. So again, the key is going to be remembering what order we would do the operations in if we knew what x was, and then reversing that. So if I knew what x was, I would first multiply it by 0.8, and then I'd divide the result by 4. So if I'm doing the opposite of that, reversing my order of operations, I'm going to undo the dividing by 4 by multiplying by 4. Okay, so 2.5 times 4 is 10, equals 0.8x. Okay, all right, now I got to get rid of that 0.8 as we multiplied by x, so I divide. And x equals, so 10 divided by 0.8. Okay, well again, I can't have a decimal out here, I got to move it over. I got to move the decimal here too. This is a whole number, so that means I'm just going to be adding a 0. Okay, so 100 divided by 8. Well, 8 goes into 10 once. Bring down to 0. 8 goes into 20 twice. Bring down another 0. 8 goes into 45 times. So I get 12.5. Okay. All right, to check it, again, I'm going to plug it in. 8.8 times 12.5 divided by 4. Okay, so if I do 12.5 times 0.8, see what I get. 8 times 5 is 40. 2 times 8 is 16, plus 4 is 20. 1 times 8 is 8, plus 2 is 10. For the decimal point, I have 2 digits after the decimal point, so I put it right there. I get 10. Okay, so 10 divided by 4 is 2.5, so that's going to check out. All right, for this one, turn this down, bring that up. So, no simplifying to do. X is being multiplied by 1/4, and then we're subtracting 3. So working backwards to undo that, I add 3 first. I get 28 equals 1/4 x. Okay, to get rid of that 1/4, I need to divide by 1/4, which hopefully you remember is the same thing as multiplying by 4. So 28 times 4 would be, well, 20 times 4 is 80. 8 times 4 is 32. Put those together, get 112. Okay. So if I check 1/4 of 112 minus 3 should give me 25. Well, 1/4 of 112 is 112 divided by 4, which is 28. Minus 3 is 25. So that works out. So 112 is my answer there. All right, so here's kind of an interesting looking one. So again, here's my x. I don't have any simplifying I can do. So I'm going to go right to my train tracks. And again, just think about what order were things done in here. So there's kind of an implied parentheses here from the fraction bars. Okay? Because if I knew what x was, I'd add 5 to it and then divide the whole thing by 10. Okay, so it's kind of like these are in parentheses. Okay, so divided by 10 would be the last thing I would do there. So that's the first thing I'm going to undo by doing times 10. Okay, so multiplying by 10 gets rid of that divided by 10. Leaves just the 5 plus x. 1/2 times 10. You might know that in your head. Otherwise, of means times. We would get 5. So half of 10 is 5. Okay. Now you may be wondering, why don't I have parentheses anymore? Well, remember, all parentheses do is tell you which ordered operation to do first. Well, this is the only operation that's left, so I don't need the parentheses to tell me this is what happens next. All right, so 5 plus x, I want to get rid of the 5, so I'll subtract it. And I get x equals 0. Okay, that is a perfectly valid answer there. Let's make sure it works. So if I replace the x with a 0, I would get 5 over 10 has to equal 1/2. Well, hopefully you can see that as a fraction that reduces to 1/2. Okay, so that works. All right. So some of the ones in the worksheet are fairly challenging. So I want to go through kind of a tricky one here to make sure we can do it. Here's one where there is simplifying to do. Okay, we got to get rid of those parentheses. So if we do that, I got negative 1.7 times 0.8. So I'll use my fraction multiplication here. 7 times 8 is 56. Here at 5, 1 times 8 plus 5 is 13. I have 2 digits after the decimal point, so it'd have to go right there. So 1.36. Now it's a negative times a positive, so that means my answer would be negative 1.36. Okay. For this, remember, you want to think of minus as plus negative. So when I'm distributing this number, I got a negative times a negative, which will give me a positive. So plus 1.7x equals negative 0.85. Okay. So that's the simplifying step. I distributed to get rid of those parentheses. And now I'm trying to get the x by itself. Well, again, if I knew what x was, I'd multiply it first, then add this negative number. Right, so I got to get rid of this first. Okay. So I'm basically subtracting negative 1.36 would be the same as adding. So if you have a negative number being added, remember, you can just add to get rid of that. Right, the negative 1.36 and the positive 1.36 are going to cancel out and go away. So I have 1.7x equals, here I have a positive plus a negative. Remember the rule is there. The positive part is bigger, so I know my answer will be positive. But to figure out what it is, I got to figure out the difference between those. I got to subtract them. So 1.36 minus 0.85. Okay, so 6 minus 5 is 1. I got to borrow here. Get a 13. 13 minus 8 is 5. So I get 0.51. Okay. Last step, got to divide by 1.7 to get rid of the times 1.7. And here I got to go back to my decimal division. There's a reason we practice this stuff first. So 0.51 divided by 1.7. I need to move the decimal 1. I'm going to need to move a 1 here. The decimal is going to go right there. 17 does not go into 5. It does go into 51, though, 3 times evenly. So exactly 3 times. That's nice. So I get an answer of 0.3. Right, and again, to check it, I'd want to plug it in. So here's the original equation, negative 1.7 times 0.8 minus x, I'm replacing that x with 0.3, equals negative 0.85. Okay, so using my order of operations, 0.8 minus 0.3 is 0.5. Okay, so when I multiply this by 0.5, I should get this, which I do. Okay, I'll let you verify that one on your own if you'd like. All right, that's it. Good luck.